Okay, lesson 2 of our first unit talks about graphs of functions. And so we can read here, it says, in the next 2 lessons, we will focus on the characteristics and key features that will be used throughout our course to analyze and describe function behavior. You will develop skills to quickly graph a function by analyzing the characteristics of function behavior, and we begin with some familiar terms. So the first thing it's going to talk about here is our vertical line test. And so if you don't remember, the vertical line test is a visual way to determine if a curve is a graph of a function or not. A set of points in a coordinate plane is a graph of y as a function of x if and only if no vertical line intersects a graph at more than one point. If every vertical line intersects a graph of a relation in no more than one point, then the relation is a function. And so what they're saying here is you can take any number of vertical lines and draw through it, and as long as each of those vertical lines only touches it in one spot, then it's going to be a function. So let's look at the first one here. So I'm going to draw several vertical lines here. Did any of them touch that graph in more than one spot of that curve? They did not. Therefore, this is a function. Look at this one. So when we draw a bunch of vertical lines here, there's a couple places here that I'm worried about. And so I want us to take note of them. All right? So I'm looking at, whoops, well, let me just erase all these. So the ones I'm worried about are right here, for one, the line that's going to go through here, 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 and here. So the question is, will those graphs eventually go straight down? The answer is no, because they're right next to, you see those dashed lines? Remember, those are vertical asymptotes. And a vertical asymptote is a line that the graph is going to get really close to, but it's never going to cross it, okay? So, and that's because if we look at just this one here, all right? So first we start out where it has like x is 1, and then we could say it's 1.5, because it's getting closer. It's 1.9, it's 1.99, and we could just keep going with those 9s, couldn't we? And the next one, we could add another 9. All right, so it's still getting closer and closer and closer to that x equals 2 where that asymptote's at, but it's never going to cross it. So because it keeps getting closer and closer and closer, it keeps going to the right a little more each time. So therefore, that's okay. And so all of these are the same thing. They're all touching up close to those vertical asymptotes. Therefore, this is still going to be a function. It passes the vertical line test. It'll never have a vertical line that'll actually touch it more than once. All right, moving on to the next one. We can already see they drew in one vertical line here for us. And so that vertical line crossed it more than once. And so does that one. And so does that one. And even though that one right there doesn't, it still has at least one vertical line that touches that graph more than once. Therefore, it's not a function. And you can see that. If you look at their ordered pairs, they both have 6 for the x. Remember, a function, x cannot repeat. So this is not a function. So instead, it's a relation. And then the last one here we can look at. We can already see again, they drew in a line for us. And we can draw in several others. Some may or may not cross it more than once. But the point is that at least one of those lines touches that graph in more than one spot, like the one that they gave us. You can see by their ordered pairs, they share, it's supposed to share the same x value. This one's wrong. It's supposed to be a positive 2. All right, they have the same x value. Therefore, this is not a function. It's only a relation. Okay, vertical line test. Then we're going to talk about x and y intercepts. So remember, an x-intercept is where it crosses the x-axis. Oops, sorry. So it's where it crosses the x-axis there. And so, let's see, I'm right over here, crosses x-axis. So it tells us the x-intercepts of the graph of f, if there are any, are the solutions of the equation f of x equals 0. That means we're going to write our ordered pair as x, comma, 0. So on your x-intercept, your y value is equal to 0. So if we're looking at a graph, we're going to look for where it crosses the x-axis, and if we're doing it algebraically, we're going to put y equals 0 into it and solve. And we always write our intercepts as ordered pairs. So then y-intercept. Y-intercept is where it crosses the y-axis. And it tells us if x equals 0 is in the domain of the function y equals f of x, then the y-intercept of the graph of f is the value of f at 0, or f of 0. That is 0, comma, y. And so for the x-intercept, we know that x will always be 0. So we can substitute algebraically x, 0 in for x, solve for y, and we'll have our y-intercept. And we're always going to write it as 0, comma, whatever that y value is. So let's try this. So in example 1 here, it says in the graph below, name the intercepts. And so I'm first going to do my x-intercept. And so I'm going to look at my x-axis, which I'm just going to put a light little line going through here. All right, and I can see that I have 3 x-intercepts. I have the first one on the left there at negative 3, 0. The one in the middle there is at 1, 0. And the one on the right there is at 4, 0. So there's my 3 x-intercepts. Then I'm going to do y-intercepts. So I'm going to draw in my y-axis here and look to see if my graph crosses it anywhere. It does right here. And so that is only at 0, negative 3. And if I'm looking at a graph, if my graph is a function, I will only have one y-intercept. Because if I have more than one y-intercept, that means that x value of it's repeated and it wouldn't be a function. Example 2 tells us find the intercepts of the function algebraically. So this is where we're going to plug in zeros for the other one. So when we look at the x-intercept, that means we're going to plug in y equals 0. All right, well remember, f of x is the same thing as y. So we have 0 equals x cubed minus 3x squared minus 4x plus 12. All right, well, when we have multiple forms of x's in there, we have x cubed, x squared, and x, that means we're going to need to see if we can factor this. So first thing when we factor, remember, well, very first thing is before we even try to factor, we've got to make sure it's set equal to 0, and it is. Then we're going to look for the greatest common factor. So here's my different terms. Do they all have anything that is in common to them, that will divide into all of them, that they all have in common? We do not. The only thing they all have in common is they're all divisible by 1. So the next thing is, remember, we're going to count the number of terms. Well, underline the terms. Remember, terms are separated by plus or minus signs. So this one has 4 terms. How do we factor those 4 terms? We're going to factor by grouping. So I like to draw a line here to split it in half. I've seen sometimes students do this. The only thing that worries me when y'all do this is sometimes y'all try to multiply right there, and that's not multiply. But if that's the way you write it, that's fine. All right, so I'm going to split it in half, and we're going to greatest common factor each side over here. So I'm going to keep my 0 equals. And then what can I take out of x cubed and 3x squared? What do they have in common? Well, the numbers, the coefficients are 1 and 3. They don't have anything in common other than a 1. But I have an x cubed and an x squared, so I can take out an x squared. You always take out the x with the smallest exponent. All right, so we're doing the opposite of distributing. So remember, in distributing, you multiply. So since we're taking it out, we're going to divide. So I'm going to divide both of these by x squared. So when I do that, x cubed divided by x squared is x, and negative 3x squared divided by x squared is just negative 3. And then I'm going to common factor this side here. We always are going to common factor out whatever that sign is. So we're going to common factor out a negative something. And then look, what does 4x and 12 have in common? Well, they're both divisible by 2, but that's not the greatest common factor. But they're both divisible by 4, and that is. So I'm going to divide them both by, oops, sorry, I meant to write that down there. me back up. We're going to take out a 4. So that means that we're common factoring out a negative 4. So we're going to put negative 4 here for both of these. So my negative 4's cancel, and I'm left with x, and 12 divided by negative 4 is negative 3. Well, now I'm down to 2 terms, because we've got this that's being multiplied, so that's 1 term, and then these 2 are being multiplied together, so that's a 2nd term. And so now we're going to greatest common factor the whole thing. Do both of those terms have anything in common? And if this one is factorable by grouping, then they will have whatever's in the parenthesis in common, okay? So I'm going to bring down my 0 equals, and they both have an x minus 3 in common, so I'm going to write it down just like what I did with that x squared above it, and we're going to divide both of these by x minus 3. When we do that, the parentheses are canceled, and so it's times, what do we have left? We have an x squared and a minus 4. But I'm not done factoring yet. X squared minus 4 is a difference of squares. So I think we did some the other day, but I don't think I wrote down the formula, so I'm going to do it here just to make sure we're okay with it. So difference of squares means we have 2 terms that each have square roots with a minus sign between them. Okay, it's a difference of 2 things that are squares. So we're going to find their square roots. So square root of a squared is a, square root of b squared is b, and we're going to plug that into the formula a plus b times a minus b. And so when I look at this one, we got 0 equals x minus 3 I can't factor, but x squared minus 4 I can. So the square root of x squared is x, and the square root of 4 is 2. So I'm going to write it as x plus 2 times x minus 2. And now we don't have anything else left to factor, so we're going to set each of our factors equal to 0 and solve. So solve them. So for the first one, I get x equals 3, which means I can write that ordered pair as 3, 0. The second one, I get x equals negative 2, which means I can write that ordered pair as negative 2, 0. And the third one, we're going to add the 2, so I get x equals 2, which means its ordered pair is 2, 0. Guys, don't try to put these all into one ordered pair, okay? I see students try to put the two of the x's together and make it an ordered pair. You can't do that. Each one of them is their own x-intercept. Each one of them gets their own ordered pair. All right. Then for the y-intercept, that's the easy one. For the y-intercept, we're going to plug in x is 0. So we get f of x equals, or we could say f of 0 equals, actually, we got 0 cubed minus 3 times 0 squared minus 4 times 0 plus 12. All right, well remember, f of x, f of 0, all that's notation, that's just y equals, okay? 0 cubed is 0, so it cancels. 0 squared is 0 times negative 3, so that cancels. 4 times 0 is 0, so that cancels. So we're only left with 12. So we get y equals 12 is our y-intercept, which means as an ordered pair, it's written as 0, 12. And so we found our x and y intercepts.